All right, here we go. This is the May 2021 QAS question and answer service test. Let's get right after it. So no calculator section. Start right off, we got a little geometry problem. So these two angles here are what's called vertical angles. So whenever two lines cross each other, they form an X. We know that these two angles have to be equal to each other. We don't know what they are right now, but I can set up an algebra equation that 5x plus 5 has to equal 7x minus 35. And now I'm just solving algebra, so I'm trying to get all my x's to one side. I like to subtract the smaller amount of x's, so I'm going to subtract the 5x's from both sides. That way I keep my x's positive. So I'm going to get 5 equals 2x minus 35. Some of you may have been able to combine two steps there and do this next step at the same time, but you add 35 to both sides. And these are going to cancel out, and I'm going to get 2x equals 40. And then divide both sides by 2, and that will give me x equals 20. Then I always want to go back and just double check. Did they want x or did they want the actual angle? But they want the value of x. So the correct answer there should be B. If I plug it in, if I plug 5 in, or 20 in for x, I get, looks like 105. And then 140 minus 35. So it checks out. They're both 105 degrees. Next one, scrolling on down to number 2. Looks like we have an absolute value equation. So absolute value, the big thing is, whenever you have the absolute value, it means how far it is away on a number line from 0. Kind of the shorthand thing is, anything that's in the absolute value, it has to give a positive answer. So for instance, the absolute value of 8 is just positive 8. It's how far is 8 away from 0 on the number line? Well, it's a distance of 8. But the absolute value of negative 8 will also give me an answer of 8 because it has a distance of 8 from 0 on a number line. So the big idea with absolute value is you always want to isolate the brackets, meaning I want to get the absolute value expression by itself, which on this problem is already done for me. And then I have to solve two cases. You know, this stuff, whatever this stuff is in here, that stuff either equals positive 8 or that stuff inside has to equal negative 8. So typically you have to solve both cases. We'll kind of see only one of these answers are going to be here. So I'll solve the first one. When I add 4 to both sides, I get 2x equals 12, which is x equals 6. So it looks like that answer is there. If that answer wasn't there, I would have to solve the second one over here. And I would get 2x equals negative 4, divide. And I would have got negative 2. That answer is not there, but it also would be a valid solution. All right, move on down to number 3. Which of the following is equivalent to that polynomial? So notice we have some powers in here. And it looks like they want me to factor this. So a couple different ways you could attack this. You could just go through and multiply the expressions out on the left until you got the same one up above. But I'm going to pull out a greatest common factor. So remember, you cannot combine these. X to the cubed and x squared are not like terms, so you cannot combine them to get 12x to the 5th. Not allowed to do that. But what I could do is 4 goes into both of those numbers. And I also could factor out an x squared. You know, there's 3 x's here, 2 x's here. The most I can pull out is 2 of them. So I'm going to factor out a 4x squared. And then I'm going to do the opposite of the distributive property. I'm going to kind of ask myself, you know, 4x squared times what will give me 4x cubed? So that would be x. And then I ask myself, well, 4x squared times what will give me 8x squared? Well, that'll be 2. So it looks like that matches up with part C here. If you do any of the other options, it's not going to come out to be the same exact expression. So that was just factor using GCF. All right, going on up to number 4. Looks like just a linear algebra equation. So if 2n plus 12 equals 26n, what is the value of 6n? So there's a couple different routes you could go here. One is you could solve the if part, like solve this and find out what n equals. And then you're going to substitute that value back in. That's probably the most traditional way. So I'll do that way first. 2n plus 12 equals 26 n's. Let's get all our n's to the right side. So I'm going to subtract 2n from both sides. And I'll get 12 is 24 times what? Divide both sides by 24. And I get n equals 1/2. But they don't want 1/2, so they want you to pick this question because they want you to stop early. Don't make that mistake. You actually have to now figure out what is 6 times n. So 6 times n, or 6 times 1/2, gives me an answer of 3. So that's kind of the traditional way. There is a faster method. So on the SAT, we're kind of concerned with speed. So let me just show you a faster method. Here on the left, when I subtracted the 2n from both sides, I noticed that 12 equaled 24n. Well, they want to know what is 6n equal. Well, if you can kind of compare this equation over here on the left, to get from 24n to 6n, if I just divide this by 4, that'll give me 6n. So I could have just divided this side by 4, which would give me 3. So a lot of times I call these solve-resolves. A lot of time these solve-resolve problems, you can manipulate the first equation to kind of cheat and get your answer in the second without doing as much work. You'll see that over and over in lots of the tests that I do. All right, moving on down to number 5. Looks like we have a quadrilateral. We have something with 4 sides. So quadrilateral ABC is shown. Which equation shows the measure of the angles? All right, well, hopefully you remember that the measure of the angles in a triangle are 180. So that's 3 sides. Every time you add a side, so I don't care if you're a diamond, rectangle, rhombus, square, whatever, you're going to add another 180. So we need to know there's 360 degrees, which looks like all of these add up to 360. So that fact wasn't quite as important. But when we add these together, we're going to have x plus 90 plus this plus this. So basically I need to add all 4 of those expressions and set it equal to 360. So correct answer here is going to be A. I just added all 4 angles, A plus B plus C plus D, to make them equal 360 degrees. Now, it would have been a little tougher if they'd have said, hey, what is x? Then I would have had to solve that whole equation, but they didn't ask that, luckily. Moving on forward to number 6. In a right triangle, ABC, the length of AC is 12, A is 40, B is the right angle. What can be determined, blah, blah, blah. Well, let's get a picture here first. So we have a right triangle. And they told me that AC is 12, but let's get the angles first. B is the right angle, so that locks in B. Angle A is 40. So let's put angle A is 40 degrees there. And this must be C then. And then the distance from A to C is 12. So that's a side length. Which of the following could we figure out? Well, could we figure out the measure of angle C? Well, yes, we could, because we have 90 and we have 40. To add up to 180, C would have to be 50. So yes, we can figure out 1. So that eliminates choice B and choice D. So now I got it down to, well, what about part 2? Could we find the length of side AB? So could we find this side? And the answer is yes. We could use trigonometry. We could actually use SOHCAHTOA here. And if I'm not going to go into a whole trig lesson, but if I did the sine when standing on angle A, all right, so A was 40 degrees. So the sine when standing on 40 degrees, so this is kind of my reference point. This is my angle. Sine is opposite. Actually, on this one I would use cosine, excuse me. Cosine of 40 is adjacent over hypotenuse. So this would be my adjacent side. This would be my hypotenuse. And I have enough where I could solve that equation. We don't need to, but just know that you could solve it using trig. So I also could get this one. So the correct answer is C, not A. All right, moving forward, number 7. In the XY plane, so these are linear. These are lines in the XY plane. So maybe I'll need a little sketch, maybe I won't. Just kind of get him on there just in case. So line L has a slope of 2. All right. So I have a line with a slope of 2. But then I have a new line. Line K is perpendicular to line L. All right, well, let's talk about that for a minute. If line L, so I'm not even going to use this chart here. If line L has a slope of 2, which I could also write as 2 over 1, because with slope I like to have a rise and a run. If I want to be perpendicular, if K is going to be perpendicular, to be perpendicular, my slope needs to be opposite, meaning if the other one's positive, I got to be negative, and I got to be the reciprocal. I got to flip it. So you want to do two things to your slope. Perpendicular lines are always going to be opposite reciprocals, or change the sign and flip the fraction. So I need a slope of negative 1/2. Well, remember that in our lines, y equals mx plus b. The number in front of the x is the slope. So these two have wrong slopes. Their slopes are -2. That's not going to be correct. So right now I have it down to c and d. But we also know that it contains the point 4, 2. So they give me an xy that's a solution that works when I put it in the equation. So let's actually substitute x for 4 and see if y is 2. So if I put x is 4 and I put y is 2, negative 1/2 times 4, well, that's a -2. So that doesn't equal 2. So I know the correct answer here cannot be C. So I got to go to the next one. And if I put 4 in here, well, negative 1/2 times 4, that's a -2, added to 4. Boom, that one checks out. So the correct answer here is D. There's other ways algebraically to do that one, but I think that's kind of the most straightforward way. All right, let's go to number 8. So we have a kind of a fraction here, c equals x divided by y. Given the equation relates these variables, c is a positive number, x is a positive number, y is a positive number, so they're all positives. How do you express y in terms of c and x? So what that means is they want it to be y equals. Notice all the equations over here are y equals. So I got to solve it for y. So in order to do that, the first thing I'm going to do, kind of do this in steps, is in order to get rid of that fraction, instead of divide by y, I'm going to times both sides by y. So this divide by y and times by y are going to cancel. So I have c times y equals x. And then to solve for y, I just divide both sides by c. And I get an answer of y equals x over c. When you do these long enough, you're going to understand that these two can simply just trade places. You know, if you think about just numbers and you say, hey, 20, let me pick some numbers that are a little bit easier. If I say 10 divided by 2 equals 5, right? 5 equals 10 divided by 2. You should always be able to trade these two numbers, and it should still work. 2 equals 10 over 5. So that's just kind of a little trick. You can know that those two can always trade positions, and it'll still work. All right, moving on down to number 9, another linear problem. This is a graph. So let's just kind of take a look at this. So f is linear. Draw my axes. The y-intercept of the graph of y equals f of x is 0, -12. So the y-intercept tells me where I cross the y-axis. So remember, this is the y-axis, this is the x-axis. So 0, 12, when x is 0 and y is -12, that's way down here. So I know I'm crossing right there, and I really don't know what the line looks like. All right, I'm just going to kind of draw. They don't tell me the slope, so I'm just going to pretend, you know, maybe it's something like that. So that's f of x. That's the function. Well, it says, what is the y-intercept of f of x plus 2? You know, what if I add 2? Well, this is a transformation problem. Whenever you add 2 at the backside, that basically means we're going to translate it up 2 units. So regardless of what the slope is, if my line's going to go up 2 units and just shift up, I've now moved from negative 12 to negative 10. So it looks like my y-intercept is going to now be right here at 0, negative 10. So that was just kind of a linear transformation problem, they call it. Moving on down, number 10. Which of the following is or are an x-intercept of the graph? And so that's a funky looking graph. That's probably a tougher graph. It's going to be rational. But it really is not important here. You don't really need to know the graph. And it's a no calculator, so you can't graph it on a calculator. But whenever I see the x-intercept, I know right now, if you're an x-intercept, all right, that means that the y value is going to be 0. All right, the y value is going to be 0. And x-intercepts are where you cross the x-axis. So where do we cross the x-axis? All right, well, one thing is when I'm looking at this up here, I'm not allowed, if these are my x values, I'm not allowed to have an x value of 0 because that would mean I'm dividing by 0. And that's an undefined function. So I know right away 3 is not in there. So that's going to kind of wipe out 2 choices right away. And now if I'm looking for x-intercepts, well, when is y going to be 0? Think about these. If I plug in negative 3 into this equation, well, I'm going to have negative 3. I'm just kind of copying this first part. I'm going to have negative 3 plus 3, negative 3 take away 2, all divided by negative 3. So what I did was I just substituted negative 3 in for x. Notice what happens. This parenthesis right here on the left becomes 0. And now it doesn't matter what everything else does. 0 times whatever is going to be 0, and then 0 divided by the bottom is going to give me 0. So I know this one works. All right, I know 1 works. Same thing's going to happen if I plug 2 in. If you plug 2 in for x, all right, I'm going to get these first parentheses here. I'm going to get 2 plus 3. And here I'm going to get 2 minus 2. And on the bottom I'll have 2. Again, 2 plus 3 is going to give me 5, which doesn't really matter because 2 minus 2 gives me 0. And 5 times 0 is going to be 0 divided by 2, which again is going to give me this 0 value, which means I'm an x-intercept. So it looks like both of these would give me a y value of 0. So the correct answer here is C. Let's be careful. Remember, you can never divide by 0. So that's why the third choice did not work. Kind of a common thing that they'll test on there. Number 11, the graph of y equals 2 to the x minus a is shown where a is a constant. What is the value of a? So depending on your knowledge here, you could use transformations. But I'm just going to kind of look at this graph. And this is kind of just a straight up algebra way. But when I look at this graph, look at this point right here. That point is a solution. And it tells me that when x equals 0, y equals negative 3. All right? When x is 0, y is negative 3. That point is on the line. So I know it must make this true. So let's substitute these values in. Negative 3 equals 2 times 0. So far I've just put both of these values in. Take away a. Well, we should be able to solve this. All right? This is just negative 3 equals anything to the 0 power is 1. That's a rule. Minus a. So I subtract the 1 from both sides. And I get negative 4 equals negative a. And now I can multiply or divide both sides by a negative 1. And it looks like a must equal 4. So the correct answer there is a. Now, if you understood the parent functions, the parent function of y equals 2 to the x power, if I was to make a table, I would find out pretty quickly in that table that if I pick 0 for x, y is going to be 1. So the parent function crossed right here. And it basically looks something like that. And I can see that we shifted down 1, 2, 3, 4 units. So I knew that this -4 meant that it went down 4 units. So that's another way to figure out the answers A using transformations if you just don't want to substitute. Either way is cool. All right, number 12. See what we got here. Looks like we got a graph. It looks like part of a parabola. And I notice all these down here at the bottom are squares. So it says we have a group of fish, body length on the bottom, tail area on the side. And it looks like all of our body lengths are going to be between 6 and 34, which makes sense because this is 6 and this is 34. So all of our L's are between those two numbers. Which equation represents the relationship between the body length and the tail area? Several ways to do this, but how about we just pick a value and try to make it fit the equation? That's usually the most straightforward way. So to me, a great crossing point is right there. And for that point right there, it looks like when L equals 15, then A has to equal 5. All right, when L is 15, A is 5. Well, if you look at all of these, if I plug L as 15 in, 15 squared, which are all of these have L squareds. If I put 15 squared in, that's a big number. That's 225. I'm supposed to get an answer of 5 out of that. All of these numbers are going to make that even bigger. 1 and a little bit times 225. 2 times 225. 3 times 225. Those numbers are huge. This number is very small. And if you do 0.02 times 225, you don't really even have to do the math. You're just going to know that that's going to shrink this number way down to where we're going to have a correct answer for something like A. I think that's kind of the most straightforward way to do that type of problem, is just find a value on the chart and plug it in, make the equation work. All right, number 13, good old-fashioned systems of equations. So I have 2 linear equations, 2 lines, and I notice that the coefficients in front are different, like they don't match up. And usually my go-to method here is called elimination. So in order for elimination to work, what I'm trying to do is I'm trying to get my coefficients. I need coefficients to be opposites, okay? Meaning like 2 and -2, or 3 and -3. Well, it looks like on this one, I'm going to have to multiply both rows to get this thing to work out. And I have some choices. If I wanted to right now, I could multiply the top row by let's say -3 and the bottom row by 8, because that would give me -24x and +24x. But those numbers are pretty big. It's going to get big. I could do that. But I'm going to look over to the y's, because I think I could get both of these to be 12s pretty easy. I think if I multiply the bottom row by 2, I'll get +12y. And if I multiply the top row by 3, I'll get -12y. So watch me multiply both rows. So I'm just going to distribute all the way across. 24x minus 12y equals 21. Now do 2 across the bottom. 6x plus 12y equals 24. And now I'm in great shape because I wanted to find the value of x. So that was another reason why I didn't try to get my x's to be opposites, because they would disappear. I wanted to get my y's to cancel out, because now that I have opposites, I can combine these 2 rows, and I'm going to get 30x's. -12 and +12 are going to cancel. I've eliminated, that's the name, I just eliminated the y's. And now I get 45. And if you divide both sides by 30, 45 divided by 30 is 1.5. So the correct answer is A. You could have reduced this fraction down. 15 goes into both these pieces. You might have started with like 3 or 9, but 15 goes into both those pieces, and you'll get 3/2, which is 1.5. Again, this is no calculator, so you got to have some basic arithmetic skills on this one. All right, number 14, another system's back-to-back. In the given system of equations, k is a constant, so k is some number. We don't know what number it is. This system has exactly one solution. All right? Well, we need to understand what that means. One solution means that when these two lines cross each other, they're going to cross at exactly one spot. And what that means is they're going to have different slopes. All right? Different slopes in order to cross each other. If this question were to ask about no solution, the only way you can have no solution is if you have two lines that are parallel to each other, which is going to make them have the same slope. And also, I might as well throw this out there, some systems have infinite solutions, meaning it's the exact same line right on top of itself. And again, these people have the same slope. So what's going to give me one solution is I need to have different slopes. And the top line has a slope of 2. So this bottom line needs to have a different slope. So it can't be that one. 5 would work. If I graph those two lines, I don't need to be really careful, but I'll just kind of show you. But 2x plus 5 means it's going to cross roughly at 5 and go up 2 over 1. So it's going to be something like that. If I put 5 in here, 5x plus 3 means I'm going to cross at 3, but now I'm going to go all the way up 5 over 1. I'm going to be really steep. And I'm going to have that one solution somewhere. I don't really care where it is, but I'll have one solution. So the correct answer here is 2 only. You can't have the ones. 5 does work, so it's not neither. So the correct answer there is B. Number 15, looks like we have an exponential problem. So I kind of see this format. And exponential problems, exponential equations or functions, you always have some starting amount. And then you're always going to have a growth factor. All right? And it's going to be growth if you are bigger than 1. All right? If you multiply something by 1, it stays the same. But if you multiply it by something bigger than 1, it's going to grow. And then this up here represents the number of times that growth happens. So I kind of know on this problem, we started with 100, and we are growing by a factor of 1.11. So you take 100, you multiply it by 1.11, you get a little bit bigger number. Then you do it again, you do it again, you do it again. So looking through here, it says, which of the following is the best interpretation of this number? So the number in parentheses is the growth factor. So the model predicts there were 1.1 beetles. No. Predicts the number of beetles increases by 1.11. No, it sounds good, but we're not just increasing by 1.11 beetles every day because it starts to become a bigger and bigger number. It snowballs. It's compounding. So that's false. Part C predicts it'll take 1.1 days. No, the 1.1 has nothing to do with the days. It predicts that the number of beetles grows by a factor of 1.11. Yes. And if you wanted to make a little chart, you don't really have to do this, but if I kind of wanted to make a chart and I wanted to be like, hey, how about we just look at beetles and you look at the number of days and you just do this a couple times, you'll kind of see what's going on. But at day 0, we had 100 beetles. Well, after one day, if I multiply by 1.11, so 100 times 1.11, there's 100. So after day 1, there's 111 beetles. We've increased by 11 beetles. Well, now I got to multiply this number by 1.11. So now we have on day 2, and this is just a model, so I can't really have 0.21 beetles, but it's growing by a little bit more. And then it's going to grow by more, it's going to grow by more, it's going to snowball. So that's why this is an exponential type problem where there's growth. Now we move into the short answer. So it looks like we have another linear problem here. So in the xy plane, the graph y equals 1/2 x plus b, where b is a constant, intersects at -6, 0. All right? So basically what they're telling me, they're giving me a solution. They're telling me that, hey, on the table, on this xy table, when x is -6, the y value is going to be 0. They give me an x and a y. So I should be able to drop that x and y in and solve for b. So I know that 0 equals 1/2 times -6. So I've just substituted these values in. And now we're going to figure out what b is. So 0 equals -3 plus b. So to solve for b, I add 3 to both sides. And it looks like b's got to be equal to 3. So correct answer, the value of b is simply 3.